Good morning, grade 12. The topic we're going to discuss this morning is equations and inequalities. The first concept that you need to master is the completion of the square. The example is, write the following expression in the form a bracket x plus b to be squared plus q by completing the square. Now the first step in completing the square is to make the coefficient of x squared 1. It is 1. The second step is keep the first two terms. Then you add half the coefficient of x. The coefficient of x is 2, so half of 2 is 1, and I square it. If I added 1 squared, then I'm subtract the same number in order to keep the expression. Because if you add 1 and subtract 1, then you've changed nothing, it remains x squared plus 2. The third step is to factorize. So what do I need to factorize? X squared plus 2x plus 1. Minus 1 squared is 1. So to factorize that trinomial, we say it is a perfect square trinomial. So it's x plus 1 multiplied by x plus 1 minus 1. The factors of x squared is x times x. The factors of 1 is 1 times 1. This says same sign, both positive, positive, positive. If you multiply that out, that means first by first, I get x squared. First by second, I get x. Second by first, I get x. X plus x is 2x, and 1 times 1 is 1. So this can be rewritten as x plus 1 squared minus 1. So I've written it in the form a bracket x plus b ought to be squared plus q. Right. In order for us to complete the square, for this, the first step is to make the coefficient of x squared 1. It is 1. The second step is to keep the first two terms. Then you add half the coefficient of x. So half of negative 9 is negative 9 over 2 to be squared. So if you added negative 9 over 2, then you need to subtract negative 9 over 2 to be squared. And this here becomes x squared negative 9x plus 81 over 4 minus, in this case, 81 over 4. Now the factors of that becomes x, same sign, both negative, negative 9 over 2 times x negative 9 over 2 minus 81 over 4. The factors of x squared is x times x. The factors of 81 over 4 is 9 over 2 times 9 over 2. And this is same sign, both negative, negative, negative. So this becomes x negative 9 over 2 to be squared minus 81 over 4. Right. In the next example, we got to rewrite 2x squared negative 7x plus 6 in the form a bracket x plus b to be squared plus q by completing the square. Now, if you get a sum like this, the first step is to take out the coefficient of x squared, which is 2. So we're going to take out 2 in this case. So we're going to say 2 bracket x squared negative 7 over 2x plus 3. I repeat, if it's 2x squared negative 7x plus 6, we've got to make the coefficient of x squared 1, so we take out 2. 2 times x squared is 2x squared. 2 times negative 7 over 2x is negative 7. 2 times plus 3 is 6. The second step is to keep the first two terms. Then you add half the coefficient of x. Now half of negative 7 over 4 is negative 7 over 2 is negative 7 over 4 to be squared. So if you add that, then you need to subtract that. So it's negative 7 over 4 to be squared plus 3. In this case, we can say it is 2 brackets x squared negative 7 over 2x plus 49 over 16 minus, this here becomes 49 over 16 plus 3. Now, in this case, we can say you can say in this case that the factors of that is 2 brackets x, same sign, both negative, negative 7 over 4 and x negative 7 over 4. And this here, we put a negative here and we get the LCD here, which is equal to 16. So it becomes 49 plus 16 times 3 gives you 48 over 16. So it becomes 2 brackets x minus 7 over 4 to be squared negative. Now 49 plus 48 gives you 97 over 16 minus 97 over 16. And if you multiply that out, 2 times that is 2 brackets x negative 7 over 4 to be squared, and 2 times that is negative 97 over 8. The next question is, show by completing the square that negative x squared plus 4x negative 9 is equal to negative bracket x minus 2 to be squared negative 5. So we're going to take the question, which is negative x squared plus 4x negative 9. Your first step is to make the coefficient of x squared 1, so we take out a negative. Negative bracket becomes x squared negative 4x plus 9. Your next step is to keep the first two terms. So I keep x squared negative 4x. I add half the coefficient of x, which is negative 2 squared. If I add 4, I subtract 4 and then I add 9. This here becomes negative bracket x squared negative 4x plus 4, and negative 4 plus 9 is plus 5. Now you can find the factors of that, so it's negative bracket. This becomes x negative 2 to be squared plus 5. Now if you multiply in by the a value here, negative times that is equal to negative bracket x minus 2 to be squared negative 5. Now what's very important is that if you've got the graph of y equal to x squared, the general equation of the parabola is y is equal to ax squared plus bx plus c. That is the general form of the parabola, and that is the equation that you learn in grade 11. Now if this a value is positive, it is the graph is arms up. If this a value is negative, it's down. So if it's positive, it will have a minimum. If the a value is negative, it has a maximum. And the maximum value will be the y coordinate of that point there, the y coordinate of the turning point. I repeat, the general equation of the parabola is y is equal to ax squared plus bx plus c. If this a value is positive, the parabola has got its arms up and it has a minimum value. And if this a value here is negative, the parabola is drawn with the arms down and it is the maximum value. And the minimum and the maximum value is the y coordinate of the turning point. Right. In this case here, we need to determine the maximum value of negative x squared plus 8x negative 12. So the maximum value is your y coordinate to the turning point, and in this case, you will see it is the value. If we look at the previous question here, this value here, because a here is negative, the arms are down, and the maximum value is this value here, which is y equal to negative 5. So this value will always be your maximum or your minimum value. I repeat, if you got the expression negative x minus 2 to be squared negative 5, this a value here is negative, means the arms is down. So it's a maximum, and the maximum value will be this value that's outside the square of the bracket, the square bracket. So let's have a look at that, and let's apply that to this. Because the a value is negative, the arms of the parabola is down, so it has a maximum value. So by completing the square, we will be able to read off the maximum value. So your first step is to make the coefficient of x squared 1. So we take out a negative. So it is x squared negative 8x plus 12. The first step is to make it positive 1. So I took out a negative. Now the next step is to keep the first two terms, x squared negative 8x. Then I must add half the coefficient of x, which is negative 4 squared. If I add 16, I'm going to subtract 16 plus 12. Now, again, if you add 16, then you must subtract 16, and this plus 12 remains there. So we can say this becomes negative bracket x squared negative 8x plus 16. And negative 12 plus 4 will give you negative 4. Now if you multiply in by that, we're going to get, in this case, negative bracket x, same sign, both negative, negative 4 to be squared, and negative is plus 4. So because a is negative, the parabola's got arms down and it's a maximum, and the maximum value is this value here. So the maximum value equals 4. That's the maximum value. Right, in this case here, we're going to do an application question of maximum and minimum. A farmer wants to fence off his cattle within a rectangular area. He has 18 kilometers of fencing, so that y is equal to 9 minus x. Now he's got 18 kilometers of fencing, and it's rectangular. So if that is x, that is x. If that is y, that is y. And the perimeter is given as perimeter is 2x plus 2y is equal to 18. Right. Perimeter of a rectangle is twice length plus twice breadth. Now if I take out a common factor of 2, I get x plus y is equal to 18. Therefore x plus y is equal to 9. So here we can say y is equal to 9 minus x. And that is what we had to prove. We had to show that y is equal to 9 minus x. I repeat the question. A farmer has 18 kilometers of fencing. If the length is x, the breadth is y, prove that y is equal to 9 minus x. Because this is the perimeter is twice length plus breadth is equal to the perimeter. So twice x plus y is equal to 18. Take out a common factor of 2. Then divide both sides by 2. So x plus y is equal to 9. But let's make y the subject to the formula, because the question says show that y is equal to 9 minus x. So in this case, I made y the subject of the formula. I took x across, became negative x, 9, negative x. Write a formula for the area in terms of x. Now, the area is equal to length times breadth for a rectangle. And the length of the rectangle is x, and the breadth here is 9 minus x. So the area is given as 9x minus x squared. That is the area formula for the rectangle. What is the largest rectangular area that can be enclosed by 18 kilometers of fencing? So they just basically want the maximum of this. Now this here is a parabola. It's negative x squared plus 9x. Because the a value is negative, the parabola is arms down, which means it's got a maximum value. And the maximum value I can determine by completing the square. So in this case, we're going to complete the square. So we're going to say that the area is equal to negative bracket x squared negative 9x. Then we're going to complete the square. So we can say negative x squared negative 9x, keep the first two terms, add half the coefficient of x, negative 9 over 2 to be squared. If I add 81 over 4, I subtract 81 over 4 in this case. Now I can find the factors of that. So it's negative. The factors of x squared is x multiplied by x. The factors of 9 over 2 squared is 9 over 2 and 9 over 2. Same sign, both negative. Negative 81 over 4. So now this becomes negative bracket x minus 9 over 2 to be squared negative 81 over 4. And a negative times that is negative bracket x minus 9 over 2, and negative negative is plus 81 over 4. Now this value here will be your maximum. So we can say the maximum, right, area. What is the largest rectangular area that can be enclosed? So the maximum is 81 over 4 kilometers squared. That's the maximum area that can be enclosed with the given dimensions. Now we're going to move on to quadratic equations. Now, to identify a quadratic equation, if the left-hand side is equal to the right-hand side, I have an equation. If the highest exponent of the variable is 2, I am busy with the quadratic equation. To solve a quadratic equation, I bring everything to the left-hand side. X squared plus 5x negative 6 is equal to 0. And then I find the factors. So the factors of x squared is x multiplied by x. Now this is opposite sign. If there's a negative, the last sign means opposite sign. One bracket gets a plus, the other gets a minus. And the factors of 6 to give you 5, and if it's opposite sign, it will be 6 and 1. Let's see whether that is correct. If you multiply the outers, x times negative 1, that will give you negative x. And if you multiply the inners, x plus 6 is 6x. So plus 6x, negative 1x gives you 5x. So those are the correct factors. So we can say that x plus 6 is equal to 0, or x minus 1 is equal to 0. So x is equal to 1, or x is equal to negative 6. Right, in the second sum, we again got a quadratic equation. Because the left-hand side is equal to the right-hand side, it's an equation. The highest exponent of the variable is 2, quadratic equation. To solve it, we bring everything to the left-hand side. We make the right-hand side 0, and now we factorize. We take out x, and it becomes x minus 4 equal to 0. So a times b is equal to 0, so a is equal to 0, or b is equal to 0. So x is equal to 0, or x is equal to 4. Remember, we've got to use the word or, not and, or. Right, in this case here, once again, it's a quadratic equation, so I take everything to the left-hand side. So it becomes negative 4x squared. 10x across becomes negative 10x. Negative 6 across becomes plus 6 equal to 0. Now, negative 2 can go into each term, so I'm going to divide by negative 2. So negative 4 divided by negative 2 is 2x. Negative 10 divided by negative 2 is plus 5x. Negative 6 divided by negative 2 is negative 3 equal to 0. Now, in this case here, we've got to find the factors. So the factors of 2x squared is 2x multiplied by x. The factors of 3, in this case, would be 1 and 3. This here is opposite sign. So one gets a plus, the other gets a minus, equal to 0. And let's see whether it's correct. If you multiply the outers, I gain to get 6x. If you multiply the inners, I get negative x. If you add them, you get plus 5x, which is the middle term. So here we can say that 2x minus 1 is equal to 0. So x is equal to a half. Or x plus 3 is equal to 0. X is equal to negative 3. So the answer in this case will give you a half and negative 3. Let's just go through this again. We take the 10x across, becomes negative 10x. The 6 becomes plus 6. Then I divide by negative 2. So negative 4 divided by negative 2 gives you plus 2x. Negative 10 divided by negative 2 is 5x. Plus 6 divided by negative 2 is negative 3. Factors of 2x squared is 2x times x. Factors of 3 is 3 and 1. Multiply the outers is 6x. Negative x gives you plus 5x, which is correct. And then you can say that x is equal to half or x is equal to negative 3. The next question, we've got to solve the quadratic equations by completing the square. Now, your first step here is to take the c value across. Now, the c value is your constant. Your a value is the coefficient of x squared, which is 1. Your b value is the coefficient of x, which is plus 4. And your c value is the value which is free of x. In this case, it's negative 6. So to solve for x by completing the square, we're going to take the c value across. So it becomes x squared plus 4x equal to 6. Then the next step is to divide across by the a value. The a value is 1. If we divide across by 1, it remains the same. The next step is we've got to add half times the coefficient of x. To be squared, we've got to add that to both sides. This time it's an equation. What we do to the one side, we must do to the other so that the equation balances. So it becomes x squared plus 4x. We've got to add half the coefficient of x, which is 2 squared. If we add 4 here, then we've got to add 4 to the other side. So this here becomes x squared plus 4x plus 4. That is equal to 10. Now the factors of x squared plus 4x plus 4 is, the factors of x squared is x multiplied by x. The factors of 4 is 2 and 4 and 1. But 2 and 2 will give you 4 in the middle. This says if it's positive, it says same sign. If it's negative, it's opposite sign. Because it's positive, it's same sign, both positive. So here we can say x plus 2 to be squared is equal to 10. And if we square root this side, we get x plus 2 is equal to plus minus the square root of the other side. And therefore, if we take the 2 across, becomes negative 2 plus minus root 10. So the answer is that x is equal to negative 2 plus root 10, or x is equal to negative 2 negative root 10. And now you can just use your calculator to determine those values. So we can say negative 2 plus the square root of 10 equals 1,16. And we can say negative 2 negative the square root of 10 equals negative 5,16. So x is equal to negative 5,16. So now we have solved the quadratic equation by completing the square. I repeat, to solve the quadratic equation by completing the square, the first step is to take the c value across, the constant across. The next step is to divide by the a value. So the a value is 1, we divide everything by 1, it remains unchanged. The next step is to add, keep the first two terms, add half the coefficient of x, which is 2, and I square it. If I add 4 to the side, I must add 4 to the other side. Then I can factorize. And then once you have got a square, to get rid of the square, we square root the side, and it becomes plus minus the square root of the other side. And then we can take the positive 2 across, and we can use the calculator to determine the values of x. Right, in this case, we're going to solve the quadratic equations by using the quadratic formula. Now, if the equation is ax squared plus bx plus c is equal to 0, and a is not equal to 0, then we can use the formula x is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a to solve for the quadratic equation. So if it hasn't got rational factors, if the roots are not rational but irrational, then we must use the formula. But this formula will work whether the roots are rational or irrational. This formula will always can be used to solve a quadratic equation. Right, let's look at the following. Here we need to solve for x. So your first step, because the left-hand side is equal to the right-hand side, we've got an equation. The highest exponent of the variable is 2, so we are busy with the quadratic equation. To solve the quadratic equation, we bring everything to the left-hand side, and we make the right-hand side equal to 0. That's standard form. We bring plus 36 across, becomes negative 36. So standard form is ax squared plus bx plus c equal to 0. Now, because this hasn't got factors, and they told us to use the quadratic formula, so we're going to say a is the coefficient of x squared, which is 1. B is the coefficient of x, which is 9. And c is the remainder free of x, which is negative 36. So now we're going to say the quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4ac all divided by 2a. So in this case, what we're going to do is we say x is equal to, the b value is 9, so it's negative 9, plus minus the square root of b squared, so it is 9 squared minus 4 times a times c divided by 2 times a, 2a. So now we can say x is equal to negative 9 plus minus the square root of 9 squared is equal to 81 plus, and negative 36 and negative 4 is plus 4. So it's 36 times 4 equals 144 divided by 2. So x is equal to negative 9 plus minus the square root of 81 plus 144. So 144 plus 81 is equal to 225, and the square root of 225 is 15. So now it becomes x is equal to negative 9 plus minus 15 over 2. Therefore, we can say that x is equal to negative 9 and negative 15 is negative 24 over 2 is negative 12. Or x is equal to negative 9 plus 15 is 6 divided by 2 is 3. And in this case, they asked us to use the quadratic formula to solve for this, but we could have also solved for it by using the factors. We could have said it is x squared plus 9x minus 36 is equal to 0. Factors of x squared is x multiplied by x. Factors of 36 is 12 and 3 will give you 9. Opposite sign, so it's negative, positive is equal to 0. So x minus 12 is equal to 0, or x plus 3 is equal to 0. X is equal to, in this case, we need plus 12. So it's plus here and minus here, and therefore x is equal to negative 12, or x is equal to 3. So I would have got exactly the same answer if I used factors, but they asked me to use the quadratic formula. Right, now in this case we have to use the quadratic formula to solve this question. So we're going to say the left hand side is equal to the right hand side. It is an equation. The highest exponent of the variable is 2. It's a quadratic equation. Bring everything to the left hand side. So it's negative 3x squared negative 7x plus 12 is equal to 0. Now we're going to divide across by negative 1. Divide by negative 1. I want to make the coefficient of x squared positive. So it becomes 3x squared plus 7x negative 12 equal to 0. Now, I cannot find the factors, so I'm going to use the formula. So I'm going to say A is equal to 3, B is equal to 7, and C is equal to negative 12. Now I'm going to use the formula. X is equal to minus B plus minus the square root of B squared minus 4AC divided by 2A. So negative B becomes negative 7 plus minus the square root of B squared, which is 7 squared minus 4 times 3 times negative 12 over 2 times 3. So it becomes negative 7 plus minus the square root of 7 squared, and that is equal to 49. And this here in negative times a negative is a positive, and the 12 times 12 is 144. So it's plus 144 over 6. So it becomes negative 7 plus minus 144 plus 49 equals 193. So it becomes the square root of 193 over 6. So now we can say it is negative 7 plus the square root of 193 equals, divided by 6 equals 1,15. So x here is equal to 1,1487, or x is equal to negative 7 minus the square root of 193 equals, divided by 6 equals, and it is negative 3,48207. So if you round off to the second decimal place, x is approximately equal to 1,15. Now if you look at the form, 8 is 5 or more, so the 4 becomes a 5. Or x is equal to, if we round off to the second decimal place, we look at the third, it's less than 5, so it remains 8. So it's negative 3,48. Remember, to round off, if I round off to the second, I look at the third. If it's 5 or more, I round up. If it's less than 5, it remains the same. Right, let's look at equations with fractions. That's the next section of work. So in this case, your first step is to get rid of the fraction in an equation. To get rid of the fraction, we multiply each term by the LCD. Now the LCD of 1 and x minus 2, so the LCD here is equal to x bracket x minus 2, and the 1 is there. So I multiply each term by the LCD. So I multiply 10 by the LCD, which is x and x minus 2, right, over x. 10 over x multiplied by the LCD, plus 3x are multiplied by the LCD, so it becomes x minus 2 over x minus 2. So it becomes 3x over x minus 2. 3x over x minus 2 are just multiplied by the LCD. And this here becomes 7 over 1, and are multiplied by the LCD, x bracket x minus 2. So that cancels out, so that cancels out, so I get 10 times that. So it's 10 brackets x minus 2 plus 3x multiplied by x, that is equal to 7x bracket x minus 2. Now let's multiply that out. It becomes 10 times x is 10x, 10 times negative 2 is negative 20, plus 3x times x is 3x squared. That is equal to 7x squared negative 14x. If you take that across, becomes 3x squared, which is that, take it across, negative 7x squared. This here becomes 10x. This becomes, take negative 14x across, plus 14x minus 20 is equal to 0. So your next step in this case, we say that minus that is negative 4x squared plus 24x minus 20 is equal to 0. I'm going to divide across by negative 4. Divide across by negative 4, so it becomes x squared. 24 divided by negative 4 is negative 6x. Negative 20 divided by negative 4 is plus 5 equal to 0. And to get the factors of this, the factors of x squared is x multiplied by x. The factors of 5 is 5 and 1, same sign, both negative. So therefore we can say that x is equal to 1 or x is equal to 5. Now if you've got a fraction in an equation, you've got to test it, because that the x value can make it the denominator 0, which will make it undefined. So here we can say that x cannot equal to 0 or x cannot equal to 2, because 0 will make it undefined, and 2 minus 2 is 0. 2 will make the denominator 0, which makes it undefined. But your answer is 1 and 5. So there's no restriction. Both answers would be applicable. In the next question, if there's a fraction in an equation, your first step is to get rid of the fraction by finding an LCD. But before we can find the LCD, we must factorize the denominators. So this becomes 5x plus 9 over factors of x squared is x minus 3 and x plus 1, negative. I'm going to change 3 minus x to x minus 3. So if I change 3 minus x to x minus 3, I'm taking out a negative. And this 2x remains. And a negative will become a positive. Just remember that negative times x is negative x. Negative times negative 3 is plus 3. And a negative will become a positive. So this here becomes x over x plus 1. So it becomes 5x plus 9 over x minus 3 multiplied by x plus 1 plus 2x over x minus 3 is equal to x over x plus 1. Now your first step is, now we can find the LCD. You first need to factorize and then find the LCD. In this case, I factorized and I had to change 3 minus x to x minus 3 by taking out a negative, and the negative became a positive. So multiply each term by the LCD. The LCD is equal to x minus 3 multiplied by x plus 1. So it becomes 5x plus 9 over bracket x minus 3 multiplied by x plus 1 times by x minus 3 multiplied by x plus 1 plus 2x over x minus 3 multiplied by the LCD, which is x minus 3 multiplied by x plus 1, which is equal to x over x plus 1 multiplied by the LCD, which is x minus 3 multiplied by x plus 1. Right, so let's just have a look here. X minus 3 cancels out, x plus 1 cancels out to give you 5x plus 9. 5x plus 9. That cancels out with that to give you 2x times x plus 1 plus 2x multiplied by x plus 1. That cancels out with that. X plus 1 cancels out with x plus 1 to give you x times x minus 3. X times x plus x minus 3. X minus 3. Right, now we just need to solve that equation. So we can say 5x plus 9 plus 2x times x is 2x squared plus 2x is equal to x squared negative 3x. So 2x squared negative x squared becomes x squared. This here becomes 7x plus 3 becomes 10x. This here becomes 7x plus 3 becomes 10x. And this here becomes 9 equal to 0. Now to find the factors, we're going to say x plus 9 multiplied by x plus 1 is equal to 0, x is equal to negative 9, or x is equal to negative 1. But remember, x cannot equal to negative 1, because if x is negative 1 plus 1 is 0, which makes it undefined. So x cannot equal to negative 1, and the answer is x equal to negative 9. Right, now we're going to look at the nature of the roots. The roots of an equation refer to the solutions of the equation. When solving a quadratic equation, one is always finding the x-intercepts of a quadratic function that is represented by the equation. The roots of a quadratic equation can either be real, non-real, rational or irrational, equal or unequal. So if you have to describe the nature of the roots, you will use one of these two, real or non-real. You'll use one of these two, rational or irrational, and you'll use one of the following, equal or unequal. Now let's quickly understand. If you got the square root of a negative number, then that is non-real. For example, the square root of negative 25, you cannot find the square root of a negative number, it's non-real. You cannot find the square root of negative 3 because it's a negative number, it's non-real. You can find the square root of positive 100, but you cannot find the square root of negative 100. The square root of a negative number is non-real. And what is a perfect square? It is finding the square root of a number that has no remainder. The square root of 25 is 5, so it is real and rational. The square root of 100 is 10, it's real and rational. The square root of 9 over 4 is 3 over 2, which is 1.5, it's real and rational. And if it's not a perfect square, then the solution is real and irrational. The square root of 10 is irrational, real and irrational. If we look at the quadratic equation, which is given as x is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a, this part here underneath the square root sign, b squared minus 4ac, is called delta. And delta can determine what the nature of the roots of the quadratic equation is. Delta will determine the nature of the roots. If delta, which is equal to b squared minus 4ac, is less than 0, is negative, the roots are non-real. If delta is greater or equal to 0, the roots are real. If delta is greater than 0 and a perfect square, like the square root of 25, then it's real, rational, and unequal. If delta is greater than 0 but not a perfect square, it's real, irrational, unequal. Delta equal to 0 gives you real, rational, and equal. Sorry, these gives you real, rational, and unequal, real, irrational, and equal. But if delta is equal to 0, it gives you equal roots, real, rational, and equal. Right, in this question here, they say determine the nature of this roots without solving the equation. So without solving the equation, we're just going to work out delta. So your A value here is the coefficient of x squared, which is 3. B value is the coefficient of x, which is 8. And your C value is the remainder free of x, which is negative 2. Remember, before I can read off A, B, and C, we've got to write the equation in standard form. That is in the form ax squared plus bx plus c is equal to 0. Now delta is equal to b squared minus 4ac, which is 8 squared minus 4 times 3 times negative 2, which is equal to 64. Negative negative is plus. Plus 24 gives you 88. And if it's 88, then we can say delta is greater than 0, but not a perfect square. And if it's greater than 0, but not a perfect square, the roots are real, irrational, and unequal. Right. The next one. Show that the roots of the equation x, 6x minus 7m is equal to 5m squared are real, rational, and unequal. So yeah, your first step is to write it in standard form. So x times 6x is equal to 6x squared negative 7mx, 7mx minus 5m squared equal to 0. I multiplied that out. I brought 5m squared across, becomes negative 5m squared. So now that equation is in standard form. So your A value is 6, your B value is negative 7m, and your C value is negative 5m squared. Remember, A is the coefficient of x squared, B is the coefficient of x, which is negative 7m, and the remainder free of x is your C value. Now, we've got to work out delta. Delta is equal to b squared minus 4ac. The b value is negative 7m squared minus 4 times a times c is negative 5m squared, which is 49m squared, and that gives you 24. 24 times 5. That gives you 120 plus 120m squared gives you 169m squared. Now you can see, because delta is greater than 0, because anything squared is positive, times a positive is a positive. So delta is greater or equal to 0, and it is a perfect square. You can find the square root of 169m squared, which is 13m. Because it is greater than 0 and a perfect square, the roots are real, rational, and unequal. Right, number C. If p bracket x squared plus x is equal to negative 9 as equal roots, determine the values of p. Now, we first got to get the equation in standard form before we can work out delta. So here we get px squared plus px plus 9 equal to 0. I said p times x squared is px squared, p times x is px, take the negative 9 across, plus 9 equal to 0. Now your a value is p, your b value is p, and your c value is 9. So delta is equal to b squared minus 4ac. So b value here is p squared minus 4 times p times 9, which is equal to p squared minus 36p. But they said it's equal roots, but delta is equal to 0 for equal roots. Therefore, p squared minus 36p is equal to 0. Now you factorize, take out p minus 36 is equal to 0. So therefore p is equal to 0 or p is equal to 36. But p cannot equal to 0. So in this case, for equal roots, the p value must be 36. The next question, we got to show that the roots of this equation are real for all real values of r. So the first step is write that equation in standard form. So here we can say it's r plus 1 x squared plus 4x plus 1 minus r is equal to 0. So here we can say your a value is r plus 1. Your b value is 4. And your c value is 1 minus r. Now, to show that it is real, we can say that delta is equal to b squared minus 4ac. Now, the b value is 4, so it's 4 squared minus 4 times r plus 1 multiplied by 1 minus r. So this here becomes 16. Now, I'm going to change 1 minus r to r minus 1 by taking out a negative, and the negative and negative becomes plus. Plus 4 brackets r plus 1 times r minus 1. So it becomes 16 plus 4 brackets r squared minus 1, which becomes 4 times that. 16 plus 4 r squared minus 4 becomes 4r squared plus 12. Now, when will it be real? If delta is greater or equal to 0. So now we can say that 4r squared is greater or equal to 0. So 4r squared plus 12 is greater than 0. Therefore, the roots are real. Remember, if r is 0, then it's equal to 0. But if that is 0, plus 12 cannot be equal to 0, can only be greater than 0. I repeat, if r is equal to 0, then 4r squared can be greater or equal to 0. But if r is 0, that is 0, and 0 plus 12 is just greater than 0. And if delta is greater than 0, then the roots are real. Right, in this case, we need to determine the value of p if the roots are real roots, and we're going to find the value of p if it is non-real roots. So, the first step is to write that equation in standard form. So we're going to say x times 4x, so we're going to say 4 x squared plus 3x plus p is equal to 0. That is 4x squared plus 3x plus p is equal to 0. Right. So a here is equal to 4, b is equal to 3, and c is equal to p. So for real roots, delta must be greater or equal to 0. So delta is equal to b squared minus 4ac. So it's equal to 3 squared minus 4 times A, which is 4, times C, which is P, which is equal to 9 minus 16P. So when will it be real roots? Then delta is greater or equal to 0 for real roots. So 9 minus 16p is greater or equal to 0. Negative 16p is greater or equal to negative 9. So p is less or equal to 9 over 16. When you divide by a negative number, you change the sign of the inequality. And when will it have non-real roots? So delta is less than 0 for non-real roots. So here we can say that 9 minus 16p is less than 0. Negative 16p is less than negative 9. So if you divide by a negative number, you change the sign of the inequality. So if p, negative 9 divided by negative 16 is 9 over 16. If p is greater than 9 over 16, then the roots are non-real. Right, now we're going to solve inequalities. Now, an inequality has the following sign. It is less than, less or equal to, greater than, or greater or equal to. I repeat, an inequality has the following signs: less than, less or equal to, greater than, and greater or equal to. In this case, we're going to solve the following inequalities. To solve an inequality, we solve it in the same way as an equation. So we're going to multiply out. This is a linear inequality. We treat it in the same way as an equation. Except in an inequality, if you divide by a negative number, you change the sign of the inequality. This here becomes 4x negative 12. 4 times x is 4x. 4 times negative 3 is negative 12. Greater or equal to 2x negative 20. Take it across. 4x negative 2x is greater or equal to negative 20 plus 12. So 2x is greater or equal to negative 8. So here x is greater or equal to negative 4. So what I did here, I said 4x, bring 2x across, becomes negative 4x. That's negative 20 remains. Take negative 12 across, becomes plus 12. I said 4x negative 2x is 2x. Negative 20 plus 12 is negative 8. If you divide it by 2, you get x. Divide it by 2, you get negative 4. In this one here, we can multiply out. So we say negative 4x plus 12 is greater or equal to 2x negative 24. So negative 4x negative 2x is greater or equal to negative 24 negative 12. So negative 6x is greater or equal to negative 36. Now if I divide by negative 6, then I change the sign of the inequality. Divide by negative 6, I get x. Negative 36 divided by negative 6 is 6. But if you divide by a negative number, you change the sign of the inequality. Greater or equal to becomes less or equal to. Quadratic equations or quadratic inequalities. Now to solve a quadratic inequality, we solve it in the same way as a quadratic equation to a certain extent. We bring everything to the left-hand side. We make the right-hand side equal to 0. Then we factorize. Factors of x squared negative 4, difference of 2 squares, x plus 2, x minus 2 less or equal to 0. Then we get the 0 values or critical values. Critical values or 0 values means which x value will make that 0. X equal to negative 2 will make it 0. X equal to positive 2 will make that bracket 0. Then I can draw it on a number line. First of all, you get negative 2 on a number line, then you get 2. First the negative, then the positive values. You start off by plus, minus, plus. And if you look, where is it less or equal to 0? Where is it negative? It's negative between those two values. So the answer is x greater or equal to negative 2, less or equal to 2. So if it's equal to, those points are included. And if it's less than, then it's open circle because the points are not included. You can also do the following. This here is a parabola. The A value is positive, so it is hands up. The critical values in this case is -2 and 2. Those are your 0 values. So where is this parabola negative, less or equal to 0? It's negative there. So it's negative there between x equal to -2 and 2. Let's look at the following. We've got to solve for x in the inequality. So here we're going to say x squared -3x -18 is greater than 0. Right, then we've got to find the factors. So the factors are x and x. This is 6 and 3, negative, positive, greater than 0. This is plus 3x, negative 6x gives you negative 3x. Then we find your 0 values or your critical values. So which x value will make that 0? X equal to 6. Which x value will make that 0? X equal to negative 3. On your number line, you get negative 3 and 6. Plus, minus, plus. Where is it positive? It's positive there and there. That's where it's positive. So it's positive for x less than negative 3 or x greater than 6. Or you could have said, this here is a parabola. The A value is positive, so it is hands up. The critical values, or 0 values, is negative 3 and 6. And where is it positive? The parabola is positive there and there. For x greater than 6 or x less than negative 3, it's positive. Right, let's look at the following inequality. We've got to solve for x in this inequality. So I'm going to say negative 2x squared plus x is greater or equal to 0. Now my first step is to go make that positive, because if that is positive, then I will be able to find the factors where the coefficient of x is positive. So I'm going to say, in this case, multiplied by negative 1, multiplied by negative 1. So if you multiply that by negative 1, you're going to get 2x squared, multiplied by negative 1, negative x is greater or equal to 0. If you multiply by negative, the sign of the inequality changes. So this actually becomes less or equal to 0. I divided across by negative, so I changed the sign of the inequality. Now I can factorize. So it's x, 2x minus 1 less or equal to 0. So my critical values is x equal to 0. X equal to 0 will make it 0. X equal to a half will make that 0. Or x equal to a half. So on your number line, you're going to get 0 and a half. You're going to get plus, minus, plus. So where is it negative? It's negative between there and there. And because it's included, it includes that value and that value. So in this case, where is it negative? For x greater or equal to 0, but less or equal to a half. Or you could have said, this here is a parabola, right? We're going to look at this line here. This line here is hands up. And the 0 value here is 0 and a half. And where is this negative? It's negative between the two, between 0 and a half. And because there's an equal sign there, equal signs must be in your answer. Right, simultaneous equations. Now the reason why we need to solve for simultaneous equations, because the application for this is to find the point of intersection of two graphs. So if this graph is y equal to x squared negative 1, which is the parabola, and this graph is a straight line graph, y minus x equal to 5, or y is equal to x plus 5, which is that, and we need to find the point of intersection between the two graphs, we need to solve simultaneously for these two equations. So we're going to say y is equal to x squared minus 1, that is equation 1. And we're going to make y the subject of the formula here. Y is equal to x plus 5, that is equation 2. Now we're going to substitute 1 into 2. So we're going to say x squared minus 1 is equal to x plus 5. And now we need to solve for x. So x squared negative x, negative 1, negative 5 is negative 6 equal to 0. And this is x minus 3 multiplied by x plus 2 is equal to 0. And now we can say x is equal to 3 or x is equal to negative 2. Now to find your corresponding y value, we're going to put x equal to 3 into there. So y becomes 3 plus 5, which is 8. And to find, if I put negative 2 in there, negative 2 plus 5 is 3. Y is equal to negative 2 plus 5, which is equal to 3. So the point of intersection is 3, 8. X equal to 3, y equal to 8. And x equal to negative 2, y equal to 3. Right, so that will give you the points of intersection for the two graphs. So the application for solving simultaneously is to find the point of intersection of the two graphs. And in this case, it is 3, 8, x equal to 3, y equal to 8. X equal to negative 2, y is equal to 3. Now, there are two straight lines with equations 3x minus y equal to 4 and 2x minus y equal to 5. They're represented in the diagram alongside. Determine the coordinates of A. Now, A can be determined by solving simultaneously for these two graphs. So I'm going to say, in this case, 3x minus y is equal to 4. Take y across. So y is equal to, take that 4 across, 3x minus 4, equation 1. I made y the subject of the formula. I took the negative y across, became plus y. I took the 4 across, became negative 4. So y is equal to 3x negative 4. The other equation is 2x minus y is equal to 5. Take the y across, y is equal to, take the 5 across, 2x minus 5, equation 2. So to solve simultaneously, I'm going to substitute 1 into 2. So I'm going to say if y is equal to 3x minus 4 and y is equal to 2x minus 5, then 3x minus 4 is equal to 2x minus 5, and I can solve. 3x minus 2x is x, negative 5 plus 4 is negative 1. Now if x is negative 1, we can work out y. 3 times negative 1 is negative 3, negative 4, negative 7. Y is equal to negative 7. So the point of intersection of the two graphs is x negative 1 and y is negative 7. Right, an application for this solving simultaneously is the following. The dimension of a carpet with a length of x meters, the length is x meters, is reduced by 3, and y, the breadth, is reduced by 2. So this is the dimensions. The area of the new carpet is 18 square meters and the perimeter of the original carpet is 48. Determine the dimensions of the original carpet. So we've got to determine the values of x and y. So let's get two equations and let us solve simultaneously. So here we're going to say the perimeter of the rectangle is 2x plus 2y, and that was 48 meters. That's the perimeter of the original carpet. The area of the new carpet, area of this is length times breadth. So here we can say x minus 3 multiplied by y minus 2 is equal to 18. So basically those are your two equations. I'm going to take out 2 here. I'm going to get x plus y is equal to 48. Divide both sides by 2. X plus y is equal to 24. Y is equal to 24 minus x, equation 1. And this here remains equation 2. Once again, if x plus y is 24, make y the subject of the formula. Y is equal to 24 minus x, equation 1, and that remains equation 2. Now I'm going to solve simultaneously. I substitute 1 into 2. Wherever there's y there, yeah, I'm going to substitute that expression. So it remains x minus 3, but this y value is 24 minus x, so this one is 24 minus x minus 2 equal to 18. So this becomes x minus 3 multiplied by 22 minus x is equal to 18. I repeat, x minus 3, this here becomes 24 minus 2 is 22 minus x is 18. Let's multiply out. X times 22 is 22x. That becomes negative x squared. This here becomes negative 66. This becomes plus 3x is equal to 18. Right, now we can say this here is 25x. This here is negative x squared. And this here becomes negative 66 and negative 18 becomes negative 84 equal to 0. Now I'm going to multiply across by a negative. So here I'm going to get x squared negative 25x plus 84 is equal to 0. So the factors of x squared is x times x. The factors of that is 21 times 4 will give you that. Same sign, both negative. So x is equal to 21 or x is equal to 4. So if x is equal to 21, then your y value, if x is equal to 21, then your y value is 24 minus 21, which is 3. Y is equal to 3. And if x here is equal, if x is equal to 4, then y is equal to 24 minus 4. So then y is equal to 20. Right. So if x is the length, then it would be 21 and the breadth would be 3. Right, because obviously x here, but both dimensions will work for the specific problem. If length is the longer side, so that would be 21 and the breadth would be 4, but both solutions will apply and both solutions will work out. This brings us to the end of equations and inequalities for grade 11. I wish you the very best of luck in you mastering this topic.